Welcome to the Deep Dive, your shortcut to being well-informed without getting lost in the noise. Today, we're plunging into the latest, most impactful AI developments from August 27th, 2025. Our mission, really just to distill the essential knowledge and insights you need to stay ahead.
That's right. And we've got quite a lineup today. 5 significant updates that I think really showcase AI's rapid evolution. We'll be dissecting Google's groundbreaking Gemini 2.5 flash image, NVIDIA's efficiency-focused Jet-Nemotron, Gnosis Research's Hermes 4 open-source model, Microsoft's very impressive Vibe Voice TTS, and Anthropic's innovative Claude for Chrome.
Yeah, it's a real snapshot of how AI is transforming everything. I mean, from creating stuff right down to the core infrastructure powering it all. Okay, let's unpack this. First up, let's talk about the model that's been making waves. You might have seen the code name nano-banana. Well, it's officially Gemini 2.5 flash image. Now, when something gets a nickname like that, you know the community's buzzing. What's the big deal here?
Well, the big deal, really, is that Gemini 2.5 flash image seems to be a massive leap in image editing and generation. What's truly fascinating is its comprehensive approach. We're seeing state-of-the-art results, yeah, and with standout strengths in maintaining character consistency, which, many models struggle with. Plus, executing highly targeted natural language edits, composing multiple images seamlessly, and even rendering text accurately within images. That's a tricky one.
Okay, and it's out there already. People can use it.
Oh, yeah. It's already widely accessible, integrated into the Gemini app, Google AI Studio, and the API, and popping up in third-party platforms, too.
So we've heard about its advanced capabilities, but how does this, translate into measurable dominance? Is there solid evidence it's really a step ahead?
Right, that's where the image edit arena comes in. It's leading by an unprecedented 180 ELO points against its closest competitor. Now, to give you context, think of ELO like chess ratings, okay? It measures skill based on head-to-head comparisons, millions of user votes in this case. 170, 180-point lead in this arena. I mean, it's like a grandmaster just consistently crushing intermediate players. It's a truly staggering margin.
Wow.
Yeah. And on top of that, users are reporting insane generation speed, all at a price point of about, 0.039 tons per image. Pretty competitive.
Okay, that level of dominance is impressive, but I've also seen chatter about something called soda fatigue. What exactly is that, and how does it play into the reception here?
Soda fatigue. Yeah, that's state-of-the-art fatigue. It's basically that feeling of being overwhelmed because, week after week, it seems like there's a new best-in-class model. It makes it hard to keep up or even really appreciate the breakthrough sometimes. So while Gemini 2.5 flash image is groundbreaking, some users are definitely feeling this exhaustion.
Are there other downsides people are pointing out?
Yeah, a few things. We're seeing reports of aggressive, maybe context-insensitive safety filters, like the model refusing edits on any image with children, regardless of context. That can be frustrating for, perfectly legitimate uses. There's also the ongoing debate about its value as a closed-source model versus open alternatives. And some specific limitations are surfacing, like apparently it performs poorly on style transfer compared to its predecessor, 2.0 flash image. Weird, right? And some issues with reliably generating multi-panel comic pages. Oh, and the images still come with a visible watermark.
Okay. So beyond the immediate creative uses, what's the sort of broader takeaway from this model's arrival, especially with those nuances?
I think this model's dominance, even with its quirks, highlights 2 critical shifts. First, just the rapid commoditization of even state-of-the-art capabilities. Companies have to differentiate beyond just raw power now. And second, that growing tension between these powerful, closed models and the open-source community's desire for transparency and control. This soda fatigue isn't just about new models. It's about the accelerating challenge for any single model to keep a lead and how that shapes innovation.
So for you, the listener.
Well, if you're a creative professional, a marketer, or just someone looking to quickly generate high-quality, consistent images for anything from social media to personal stuff, this model could really be a game changer, despite, some of the current quirks and the desire for more open access.
That's a fascinating dive into the creative side. Okay, let's pivot now from the visible outputs of AI to the invisible engines powering it. Let's shift gears to foundational tech. NVIDIA has unveiled Jet-Nemotron, and they're claiming major speedups in LLM inference. Expert, I see this headline, 53x faster generation. My skepticism radar immediately pings. Is that really what it sounds like, or is there a catch?
Yeah, you're right to be skeptical, and frankly, the community had the same reaction. That 53x figure is dramatic, but it definitely comes with nuance we need to unpack. NVIDIA is getting these gains through a technique called post-neural architecture search, or post-NAS. Imagine post-NAS as like an AI engineer that automatically tweaks the internal wiring of a language model after it's trained, finding the most efficient way for it to process info without losing accuracy. The reports do show 53.6 times higher generation throughput and 6.1 times faster prefilling compared to baselines like Qwen 3 and Llama 3.2, and crucially without sacrificing accuracy.
Okay, still a massive claim. But NVIDIA reports these figures. The community scrutinizes. What's the sort of real-world take on these numbers?
Right. So while the raw throughput number is high, some independent analysis suggests the actual end-to-end inference speedup for a complete task might be closer to 7 times. Not the full 53. But hey, even a 7x speedup, that's a 700% improvement. That's still substantial. Definitely not something to scoff at when you're talking about running these huge models efficiently.
Absolutely. 7x is still huge. What else does the paper talk about regarding efficiency, beyond just speed?
Well, beyond the headlines, it also highlights impressive KV cache reductions like 10 to 60 times. The KV cache is basically the model's short-term memory during processing. Reducing it is vital for managing memory footprint, especially with long contexts. They also report minimal slowdown for long context decoding, which is key for handling big chunks of text without bogging down.
Any other discussions around it?
Yeah, there's been some debate around the training cost. Reports cite around 20,000 H100 GPU hours for roughly 2 billion parameter model. Some find this kind of contradicts NVIDIA's claim that it's not as expensive as soda for training. So questions about the overall economics are being raised.
Right. So why should you, listening now, care about these technical breakthroughs? What's the bigger picture here?
This isn't just about making AI faster. It's really about changing the fundamental cost curve of deploying AI. NVIDIA focusing on inference efficiency with post-NAS signals is shift, I think, from just training massive models to making them economically viable to run at scale, maybe even on consumer hardware eventually. This could unlock a future where advanced AI isn't just in the cloud, but it's embedded in our everyday devices, driving hyper-personalized private experiences. It could really democratize access and make local on-device AI a reality sooner.
Okay, interesting. Let's turn our attention now to the open source community. Nana Research's Hermes 4, described as a hybrid reasoning model with open weights, a different approach. What makes this one stand out?
This model is interesting, yeah, because it focuses really intently on steerability, how well you can guide its behavior, and achieving low refusals, while also performing strongly on tough benchmarks like math, coding, STEM stuff. It even has this unique thinking mode you can toggle on or off. Gives users more control over its process. And No's research claims it gets state-of-the-art results on a values conformance and alignment metric, and importantly does so without censorship.
Okay, that without censorship claim for Hermes 4 is definitely bold, right? Especially with all the debates about AI safety and alignment. How do they actually achieve that balance? Can a model really be uncensored but still safe?
That's exactly the tightrope walk Hermes 4 is trying, yeah. News research claims it achieves top results on values conformance precisely by focusing on steerability instead of just blunt censorship. The community is definitely watching closely because it raises that fundamental question. Where is the line between maximizing instruction following and maintaining robust safety? Can you get broad utility without enabling harm? It's already out there on Hugging Face and OpenRouter, so developers can actually grab it, experiment, and evaluate these claims themselves.
Has there been any other community discussion around it?
Well, some discussion about its continued use of a Llama 3 base. People questioning the rationale compared to maybe using other backbones. But the general reception seems pretty positive, especially given those alignment claims aiming to stick close to user preferences while minimizing unnecessary refusals.
So for our listeners, what's the practical takeaway here with these open source advances?
Look, for developers and users who really prioritize transparency, customizability, and models that are highly steerable without being overly restrictive, Hermes 4 represents a significant step in the open source world. It's about having more control over the AI's behavior and values, giving you the flexibility to adapt it to your specific needs and ethical considerations without hitting arbitrary roadblocks. It kind of challenges the idea that strong safety must mean sacrificing utility.
Now let's switch gears again and talk text-to-speech. Microsoft has open-sourced Vibe Voice TTS. The capabilities sound incredibly promising, especially for content creators, anyone needing high-quality spoken audio. What makes this different from other TTS we've heard about?
Right, this is a neural TTS system. Comes in 1.5 billion and 7 billion parameter variants, and its key features are genuinely impressive. It supports long-form synthesis up to 90 minutes per generation. That's huge for audio production, way beyond just short clips. Even more, it offers native multi-speaker mixing, up to 4 concurrent voices in one output. Plus, you can use it in a single-speaker audiobook mode. So it's incredibly versatile for podcast, narration, all sorts of things.
Wow, 90 minutes and multiple voices. That does sound incredibly useful. What are the early users saying? Quality, performance.
Early reports are pretty glowing, actually, highlighting strong prosody, the rhythm and intonation and expressiveness, making the speech sound remarkably natural, engaging. People are calling it genuinely practical for podcasts and audiobook workflows already. One user on Windows 11 with a powerful RTX 4090 graphics card reported the Big 7B model uses about 19 gigabits of VRAM and runs at roughly 0.5 times real time, so about 2 minutes of compute for 1 minute of audio. It needs muscle, yeah, but the quality seems to justify it for professional use.
Any other features that make it stand out for audio production?
Well, we've also learned its voice cloning quality gets significantly better with around 30 seconds of reference audio. Captures vocal nuances pretty impressively. It supports both English and Mandarin, which is great for broader use. And there's a smaller 0.5B model apparently coming soon, which could lower the hardware barrier, make it more accessible. But really, the ability to mix distinct speakers and generate such long-form, high-quality audio, that marks a significant advance, moving beyond single voice, short outputs to enabling complex audio stories.
Okay, breaking this down for your workflow, what opportunities does Vibe Voice TTS open up for content creators?
I mean, imagine generating entire audiobooks, right?
Yeah.
Or multi-character podcasts, professional voiceovers, all with this level of quality and control just from text. It makes high-quality audio production so much more accessible and efficient, especially for individuals, smaller studios, people who might not have the budget or time for pro voice actors. It's not just automation, it's a huge boost for creative possibilities and productivity for anyone working with spoken audio.
Okay, finally, let's look at Anthropic's move into browser integration, their Claude for Chrome research preview. Feels like a significant step towards more integrated, powerful AI agents living right inside our digital environments. What's the core idea here?
Yeah, this is Anthropic piloting a browser-integrated actioning agent. So it doesn't just talk, it potentially does things in your browser. Currently limited to a small group, just 1,000 users. And the crucial aspect here is the strong emphasis on safety, especially robust prompt injection defenses.
Okay.
They want that nailed down before any wider rollout. Because, integrating AI directly into the browser raises complex security and privacy questions. The agent would have access to a lot of your online activity and data. Anthropic seems to be taking a cautious, responsible approach.
So Anthropic is making an agentic push, yeah, trying to bring Claude's smarts directly into our daily web browsing. But what does that actually mean for how we interact online? What tasks could it handle? It sounds like a digital assistant on steroids.
Precisely. On steroids is a good way to put it. A browser-integrated agent could do a lot across multiple websites. It could summarize complex articles or research papers for you instantly, assist with writing emails, pulling context right from the web page you're on, maybe even intelligently fill out forms online, freeing you up. The challenge, as Anthropic recognizes and is prioritizing, is stopping it from being manipulated through prompt injection. That's where, external web content or subtle cues could hijack its instructions, make it do bad things. This laser focus on safety before release really shows a responsible approach to what could be a very powerful tool.
Looking at the bigger picture then, how could Claude for Chrome shift how you will interact with the internet?
Well, for you, the listener, a browser-integrated AI agent like this could drastically change how you use the internet, offering potentially unparalleled productivity and information synthesis, like having a super assistant for your web tasks.
Yeah.
But it also raises that important question, doesn't it? As AI becomes an active participant in our browsing, how do we ensure it truly serves our interests? How do we maintain our digital security? And ultimately, how do we make sure we stay in control of its actions and its access to our data? Big questions.
Absolutely. What a journey through today's AI headlines. Wow. From Google's nano-banana revolutionizing image editing, NVIDIA's Jet-Nemotron promising that speed boost for the whole ecosystem. To NUS researches open-source Hermes 4 offering steerable intelligence, Microsoft's Vibe Voice creating realistic multi-speaker audio, and Anthropic's Claude for Chrome venturing into browser agency. It's just so clear that AI isn't just advancing, it's specializing and becoming more deeply integrated into, well, every part of our digital lives.
Indeed. And the insights from today really highlight that dual trend, I think. On one hand, incredible innovation in specific niches. On the other, these ongoing crucial efforts to make sure these powerful tools are safe, accessible, and truly beneficial. And as these AI tools get more specialized, more integrated, it leaves us with a provocative thought maybe. How do we ensure that we maintain critical understanding and control? How do we avoid just outsourcing our intelligence or maybe even our creative agency? And what new boundaries get tested when these distinct advancements, the image generation, the fast inference, the steerable models, the voice synthesis, the browser agents, when they all start to converge into even more powerful multimodal agentic systems? How will we manage that complexity in our daily lives?
Powerful questions for us all to consider. Thank you for joining us on the deep dive. We hope you feel a little more well-informed and perhaps a lot more curious.